Hello student, in this video we are going to learn second order reaction. We can define second order reaction in this way. A reaction is known as second order reaction in which the rate of the reaction depend upon the concentration of two reactants or the square of the concentration of single reactant. याचा अर्थ rate of reaction is determined by means of two concentration terms. दोन रिॲक्टंटच्या कॉन्सन्ट्रेशन वरती डिपेंड असेल किंवा एकाच रिॲक्टंटच्या स्क्वेअर वरती डिपेंड असेल, कॉन्सन्ट्रेशनच्या स्क्वेअर वरती डिपेंड असेल. दॅट्स वाय इट इज कॉल्ड एज ए second order reaction. Now let us see the example. The first example is that hydrolysis of ethyl acetate by means of sodium hydroxide. When ethyl acetate reacts with sodium hydroxide, there is a formation of sodium acetate and that of the ethyl alcohol. Now the rate of this reaction depends upon the concentration of NaOH as well as concentration of ethyl acetate. That's why it is a second order reaction. Now the second example is that the thermal decomposition of ozone into the oxygen. The ozone get converted into the oxygen. Here the two molecules of ozone are involved in this reaction. That means the rate of reaction is depend upon the square of the concentration of the oxygen, ozone. That's why it is a second order reaction. Now thermal decomposition of nitrous oxide into the nitrogen and the oxygen. Here the two molecules are involved and the rate of reaction it depends upon the concentration of this nitrous oxide. Therefore it is a second order reaction. Now then thermal decomposition of nitrogen dioxide into the nitric oxide, it is also a second order reaction. Here the rate of reaction is depend upon the square of the concentration of the nitrogen dioxide. That's why it is a second order reaction. Now the rate equation of second order reaction is carried out in two ways. दोन पद्धतीने आपल्याला कायनेटिक इक्वेशन याचं काढता येतं. एक दोन पॉसिबिलिटीज आहेत तिथं. एक दोन्ही रिॲक्टंटचं कॉन्सन्ट्रेशन सारखं असू शकतं किंवा दोन्ही रिॲक्टंटचं कॉन्सन्ट्रेशन हे वेगवेगळं असू शकतं. म्हणजे इनिशियल कॉन्सन्ट्रेशन हे वेगळं असू शकतं किंवा इनिशियल कॉन्सन्ट्रेशन सारखं असू शकतं. Therefore we have to find out the kinetic equation by taking different or unequal concentration of the reactant, that is A is not equal to B condition, and second condition we can find out the rate equation by taking equal concentration of reactant, that is A is equal to B. Therefore the rate equation for second order reaction when reactant have unequal or different concentration, that is when A is not equal to B condition is there, both the reactant is having different concentration, then we have to find out the kinetic equation. For that purpose let us consider a general second order reaction in which both reactant have different concentration. Now here reactant A and reactant B combines together to form the product. Now both reactant is having different concentration, therefore let A moles per liter be the concentration of reactant A and B moles per liter be the concentration of reactant B. Both the concentrations are different. Let X moles of A and X moles of B get decomposed into the product at the time T. Therefore the product concentration will be the X moles per liter and the concentration of reactant A will be A minus X and the concentration of the reactant B will be B minus X. इथं आपण एक रिॲक्शन घेतलेली आहे ज्याच्यात रिॲक्टंट कॅपिटल A आणि रिॲक्टंट कॅपिटल B कंबाईन्स टू गिव्ह द प्रोडक्ट. इनिशियल स्टेटला ज्यावेळेस टाईम हा 0 असतो, रिॲक्शन सुरुवात व्हायची आहे, त्यावेळेस रिॲक्टंट Aचं कॉन्सन्ट्रेशन आहे स्मॉल A मोल्स पर लिटर. दॅट इज द इनिशियल कॉन्सन्ट्रेशन ऑफ द रिॲक्टंट A. तसंच B हा जो रिॲक्टंट आहे त्याचं कॉन्सन्ट्रेशन आहे B मोल्स पर लिटर. नाउ ॲट द टाइम T the X moles of A and X moles of B combines to form the product. Therefore the product concentration will be X moles per liter. and therefore the remaining concentration of reactant A will be A minus X and reactant B will be B minus X, as A and B is the initial concentration of reactant A and reactant B respectively. Now, at the time t, if you apply the law of mass action, the rate of reaction is given by means of dx by dt is proportional to molar concentration of reactant A into molar concentration of reactant B. Now, this proportionality is converted into equal to by putting a constant k. Dx by dt is equal to k into molar concentration of A into molar concentration of B, where k is a proportionality constant known as the rate constant for second order reaction. Now, put the molar concentration of A at time t, it is A minus X, and molar concentration of B at time t, it is B minus X. In this equation, here we get dx by dt is equal to k into bracket A minus X into another bracket B minus X. Now, rearrange this equation. Now, dx upon A minus X into B minus X is equal to k dt. Now, this equation can be rearranged and can be written as 1 upon B minus A into bracket 1 upon A minus X minus 1 upon B minus X bracket close dx is equal to k dt. Now, if you solve this, you will get this equation. Now, integrate the above equation, we will get, if you integrate it, integration 1 upon B minus A into bracket 1 upon A minus X minus 1 upon B minus X bracket close into dx is equal to integration k dt. Now, in this case A and B are the constant, therefore this term remains as it is 1 upon B minus X. Integration of 1 upon A minus X dx will be minus ln A minus X. Now, this minus, now the integration of 1 upon B minus X dx is equal to minus ln B minus X, minus minus becomes plus. Now there should not be dx, हे dx चुकून आलेला आहे, इथं dx असायला नाही पाहिजे कारण इंटिग्रेशन केलं आपण, राइट, इज इक्वल टू इंटिग्रेशन ऑफ k is a constant as it is dt, integration of dt is t plus c. Or if you rearrange it, if you take negative sign outside, then it will becomes B minus A becomes A minus B, this becomes plus ln A minus X, and this plus becomes negative, that is minus B minus X. Applying logarithmic rule, we can say that ln A minus X divided by B minus X is equal to kt plus c, equation number 1, where c is the integration constant. It can be determined by applying initial condition, that is when the reaction is to be started, time is 0, at that time the amount of product, that is x, is 0. Therefore, this equation becomes, if you put the value of x is 0, here is the x is 0, value of t is 0, in this equation 1, we will get 1 upon A minus B ln A upon B is equal to c, or c is equal to 1 upon A minus B ln A by B, equation number 2. Putting this equation 2 in equation 1, putting this equation in equation 1, we will get 1 upon A minus B ln A minus X upon B minus X is equal to kt plus 1 upon A minus B ln A by B. Now, transfer this term on the left side, it becomes negative. By applying logarithmic rule, we can write 1 upon A minus B ln B into A minus X upon A into B minus X is equal to kt. Rearrange it for k, therefore k is equal to 1 upon T into A minus B ln B into A minus X upon A into B minus X, or k is equal to 2.303 T A minus B log of B into A minus X upon A into B minus X, equation number 3. Now, this equation 3 is kinetic equation for second order reaction when both reactant have different concentration. Now, this is the kinetic equation for the second order reaction when both reactant have different concentration. That means there is A is not equal to B condition. In this way, we derive the kinetic equation for second order reaction when both reactant is having different concentration. Now, let us derive the another equation for second order reaction when both reactants are having the equal concentration, that is A is equal to B. Now, let us consider a simple second order reaction in which both reactants have same or equal concentration. That is A plus B gives the product P. Let A moles per liter be the initial concentration of reactant A as well as reactant B, as both reactant is having the same concentration. दोन्हीचं concentration सारखं आहे म्हणून A moles per liter हे A आणि B दोन्हीचंही concentration आहे, right? That is A is equal to B. When the time is T is equal to 0, that means just reaction is to be start. At that time, the product concentration will be 0. Now, let X moles of reactant A and B get converted into the product, and therefore, the product concentration will be the X moles per liter at the time T is equal to T second. Therefore, the remaining concentration of A will be the A minus X and B will be the A minus X. दोन्हीचं concentration A minus X असेल, right? Now, apply the law of mass action at the time T and find out the rate of reaction. It can be given as dx by dt proportional to molar concentration of A into molar concentration of B. Convert this proportionality sign into equal to sign. Therefore, dx by dt is equal to K into molar concentration of A into molar concentration of B, where K is the proportionality constant, which is known as the rate constant for the second order reaction. Now, put the value of molar concentration of A at time T, it is A minus X. Value of molar concentration of B, it is also A minus X. Therefore, dx by dt is equal to K into molar concentration of A minus X into molar concentration of A minus X is equal to K into A minus X bracket square. Now, if we rearrange this equation, we will get dx upon A minus X bracket square is equal to K dt. On integrating above equation, we get integration dx upon A minus X square is equal to integration K dt. If we solve this integration, we will get 1 upon A minus X is equal to K. Integration of dt is T plus C, where C is a integrating constant. Now, to find out the value of C, apply initial condition, that is T is equal to 0, X is equal to 0, the equation 1. Now, this is the equation number 1. This equation 1 becomes 1 upon A minus 0, X is equal to 0 ठेवला is equal to K into 0 plus C. Therefore, C is equal to 1 upon A, equation number 2. Putting equation 2 in equation 1, we will get 1 upon A minus X is equal to KT plus 1 upon A. 1 upon A minus X minus 1 upon A is equal to KT, or X upon A into A minus X is equal to KT, or if we rearrange it for K, it is 1 upon T into X upon A into A minus X, equation number 3. Now, this equation 3 is a rate equation or the kinetic equation for second order reaction when initial concentration of both reactant is equal or the same. Now, in this way, we derive the another kinetic equation for second order for a condition A is equal to B that is both reactant is having same concentration. Now the question is asked, find out the velocity constant, show that the second order velocity constant or rate constant depend on the concentration of unit in which it is expressed. Actually we have to see the characteristics and after that we have to explain it. Now the characteristics of second order reaction, the unit of rate constant of second order reaction is liter mole inverse time inverse. Now the second order rate constant depend upon the concentration unit in which it is expressed. Concentration च्या unit वरती depend आहे ज्याच्यात ते express केलेला आहे. The value of rate constant K remains constant, spelling चुकलं इथं, remains constant for each value of x and t. The half life period of second order reaction is inversely proportional to initial concentration of a reactant. The time taken for completion of certain fraction of second order reaction is inversely proportional to the initial concentration of reactant. When one of the reactant is present in large excess, the second order reaction becomes first order reaction. Now these are the characteristics of the second order reaction. Now on these characteristics sometimes a separate question is asked. Now let us see one by one. Now show that the second order velocity constant or rate constant depend on the concentration unit in which it is expressed. याचा अर्थ रेट कॉन्स्टंट हे कॉन्सन्ट्रेशनच्या युनिटवरती डिपेंड असतं, हे प्रूव्ह करायचं आहे आपल्याला, राईट. फॉर दॅट पर्पज हिअर वी कन्सिडर द kinetic equation, that is K is equal to 1 upon T x upon A into A minus x. This is the equation number 3. Let us consider the new unit be the m times the first one. म्हणजे आधीचं जे काही युनिट आहे तुमचं कॉन्सन्ट्रेशनचं ते काय केलं आपण m टाइम्स घेतला, ते आपण त्याला बदललं, राईट. मग असं जर असेल तर तुमचं जे इनिशियल कॉन्सन्ट्रेशन A होतं, इट बिकम्स m into A and the concentration x becomes m into x. Therefore this equation becomes k dash. आता हे झालं k dash कारण इथं आपण युनिट बदललं आहे म्हणून नवीन रेट कॉन्स्टंट k dash is equal to 1 upon t. x च्या जागी काय आला mx, a च्या जागी ma, हे a च्या जागी ma, राईट. आणि इथं ह्या x च्या जागी इथं सुद्धा mx आहे, x प्रिंट झालं नाही इथं, इथे x आहे, इज इक्वल टू. आता इथं ma आणि mx याच्यातलं m जर बाहेर काढला तर एक m कॅन्सल होईल, फक्त इथं एकच m राहील, ते इथं लिहिलेलं आहे 1 upon m 1 by t x upon a into a minus x. Now this term, that is 1 by t x upon a into a minus x is equal to k, is equal to k, and therefore we can write k dash is equal to 1 upon m into k. Thus the new value of rate constant k dash becomes 1 upon m times the original value k. याचा अर्थ नवीन रेट कॉन्स्टंट जे आहे हे 1 by m टाइम्स झालेलं आहे ओरिजिनल रेट कॉन्स्टंटच्या. याचा अर्थ दिस प्रूव्स दॅट द रेट कॉन्स्टंट डिपेंड अपॉन द कॉन्सन्ट्रेशन युनिट इन विच इट इज एक्सप्रेस्ड. म्हणजे तुमचा रेट कॉन्स्टंट हे कॉन्सन्ट्रेशनच्या युनिटवर डिपेंड आहे, ज्याच्यात ते तुम्ही मांडलेलं आहे किंवा लिहिलेलं आहे, राईट. सेकंड, शो दॅट हाफ लाईफ पिरियड ऑफ सेकंड ऑर्डर रिॲक्शन इज इनवर्सली प्रोपोर्शनल टू द इनिशियल कॉन्सन्ट्रेशन ऑफ रिॲक्टंट. म्हणजे हाफ लाईफ पिरियड हा इनवर्सली प्रोपोर्शनल आहे हे दाखवायचं किंवा प्रूव्ह करायचं. पुन्हा आपण इथं kinetic equation घेतलं आहे, k is equal to 1 upon t x upon a into a minus x. Rearrange it for t is equal to 1 upon k x upon a into a minus x. Let us consider the case half of the reactant decompose into the product. At that time t is equal to t half and x is equal to a by 2. If put the values, t च्या जागी t half 1 upon k as it is, x च्या जागी काय येईल a by 2, a as it is minus a by 2. Now A madun A by 2 गेलं, इथं राहिलं A by 2. Now this A by 2, this A by 2 get cancelled. Here we get T half is equal to 1 upon K into A. Now K is the constant, therefore we can say that half-life period for second order reaction is inversely proportional to the initial concentration of a reactant, right? In this way we prove that the half-life of second order reaction is inversely proportional to the initial concentration of a reactant. Now then, another question may ask, show that when one of the reactant is present in large excess, the second order reaction becomes the first order, right? Now here we consider a reaction, rate constant when A is not equal to B, that is K is equal to 2.303 divided by T into A minus B log of B into A minus X upon A into B minus X. Now let initial concentration A is present in large excess. A जे concentration आहे reactant A चं ते excess घेतलेलं आहे, so that the product concentration X and the reactant concentration B can be neglected as compared to A. म्हणजे जिथं A च्या सोबत हे X आणि B असतील ते negligible आहेत, एवढं A चं concentration जास्त आहे. म्हणून आता इथे A च्या जवळ X आहे म्हणून X इथं 0 झाला, म्हणून इथं राहिलं BA. इथं सुद्धा A जास्त आहे, B स्मॉल आहे, म्हणून इथं फक्त काय राहिलं A राहिले, म्हणून इथं 2.303 TA log of B into A as it is B minus X, right? Now this A and this A get cancelled. Here we get, if we shift this A on left side, it is K into A is equal to 2.303 divided by T log of B upon B minus X. Now this is a kinetic equation for a first order reaction. हे इक्वेशन कशाचं आहे? फर्स्ट ऑर्डरचं आहे, जिथं इनिशियल कॉन्सन्ट्रेशन काय आहे? B आहे, right? Now this term K into A will be new constant, therefore K dash is equal to 2.303 divided by T log of B upon B minus X. Now this is a kinetic equation of first order reaction. It means that when one of the reactant is present in large excess, now again here is the spelling mistake, the second order reaction becomes the first order. It's a second order reaction काय होते? First order. Clear? Now this is about the second order reaction. Now we will stop here. Thank you.